Hello everyone, welcome to statistics class. If you have not subscribed yet to my channel, please subscribe, press bell icon and press all button so that you can get instant notifications of more videos. In today's class, we shall observe 5 marks important and most likely questions based on the chapter Interpolation and Extrapolation. In that, we have already worked out in the previous video binomial expansion method problems. In today's class, we shall concentrate on Newton's advancing difference method problems. By chance, if you have not yet observed binomial expansion method problem solving, link has been given in the description box. You can watch it. Let's concentrate on problem solving based on Newton's forward difference method. Here is the question given. Using Newton's forward difference method, interpolate the value of y when x equal to 25. The data has been given like this: census years and the population. Census years, let them be taken as x and the population will be considered as y. In this question also, which has been mentioned or, it is the another way of asking the question. You can observe or this question. Interpolate the value of y when x equal to 25. Everything is similar when we compare to this particular problem. Only the change is using Newton's forward difference method. It is mentioned here. It is not mentioned Newton's forward difference method here. Sometimes it will be asked in the examination like this also, without mentioning the method. Interpolation and extrapolation problems will be given. Then how to decide which method has to be applied for which kind of problems we have to understand. Last video you have already seen. See here one of the examples I have taken from the previous video. Here for 1918 the value was to be calculated and 1991 the value was to be calculated. Here x as years and y as the production we had taken. For the given values of x, y was to be calculated. Again here also for the given value of x, y value was to be calculated. Here it is given x equal to 25. Whether that value is given here among the x values given census years? No. For in between the values of x, it has been asked. So at this case, we have to apply Newton's forward difference method. By chance, it is exactly for x given values, y if it is to be calculated, then binomial expansion method has to be applied. Hope it is clear, students. Okay, now let us concentrate on solving this particular problem. We shall take down first the given values, x as census years and y as population in terms of crores we shall consider first. These given y values, let us name them as y0, y1, y2, y3 and y4. Similarly, x values as x0, x1, x2, x3, x4 we can name them. Then first let us concentrate on Newton's forward difference method formula, that is yx is equal to y0 plus x into delta 0 1 plus x into x minus 1 divided by 2 factorial into delta 0 2 plus x into x minus 1 and x minus 2 divided by 3 factorial into delta 0 3 plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial delta 0 4 plus so on. This is what is the formula based on Newton's advancing difference method. How to write this formula? Once again, you can observe yx is equal to y0 first and then plus x into delta 0, 1. And this x becomes x into x minus 1. Nothing is there here in the denominator, means 1 factorial is there. 1 factorial is nothing but 1 only. How to calculate factorials? You may be already knowing. 2 factorial is 2 multiplied by 1, that is 2. 3 factorial is 3 multiplied by 2 multiplied by 1, that is 6. 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1, that is 24. Like this, from that particular value in a decreasing order till 1, they are to be continuously multiplied in order to get that exact factorial values. So 1 factorial is already 1. That's why here it was not mentioned. 1 factorial is 1 in the sense anything value which is divided by 1 will remain as it is. That's why it was not written here 1 factorial. So this x is becoming x into x minus 1, and then x into x minus 1 into x minus 2, and then x into x minus 1, x minus 2, x minus 3, and this 1 factorial becoming 2 factorial, 3 factorial, and 4 factorial. And then this delta 0, 1 is becoming delta 0, 2, delta 0, 3, delta 0, 4. Very simple formula, students. You can have a practice of writing this, then it will become very easier. Now, here what is x then? We have to substitute the values in this particular formula in order to get the final answer, where this x is equal to x minus x naught divided by h. You can write where x equal to x minus x naught divided by h. What is this x is? The value of x to be interpolated in the question. For what value of x the value of y is asked, that is what is this particular x value, that is given here 25. So 25 minus x naught or x0, we have written here, see, x0 to be 10, then divided by h. H is nothing but the common difference what these x values are having. 10, 20, 30, 40, 50 is given. That's why 10 is the common difference. H value is 10. When you perform this, 25 minus 10 divided by 10, you are going to get 1.5. So x value we have got. After that, x minus 1, x minus 2, x minus 3 are to be substituted here. That's why let us keep them calculated. Therefore, x minus 1 is equal to, x value is 1.5 minus 1, that is 0.5. Then x minus 2 is equal to, x value is 1.5 minus 2 is equal to minus 0.5. Then x minus 3 is equal to 1.5 minus 3. Is it not minus 1.5? Yes. So now we have got all these x, x minus 1, x minus 2 and x minus 3 values for the substitution, and then we have to calculate these delta 01, delta 02, delta 03 and delta 04 values. Other than that, 2 factorial, 3 factorial and 4 factorial, how to calculate, we already know. So let's concentrate on the forward difference columns calculation, that is delta 1. This is first order difference column. How to calculate those first order differences is, these y values are to be considered. From second value, first value has to be deducted. That means 48 minus 55. It is minus 7. Then third value minus second value. 39 minus 48. It is minus 9. Then in the similar way, 26 minus 39. It is minus 13. And then 7 minus 26 is nothing but minus 19. So first order differences we have got. Next we have to go for second order differences. Minus 9 minus of this minus 7. So once when both are minus, we have to be extra cautious. One calculation I'll perform and show here. Minus 9 and minus 7 are the given values. So we have to minus this minus 7 from minus 9. Now, minus 9 minus of minus 7. That means minus 9 as it is, minus into minus, it will become plus 7. Minus 9 plus 7 is minus 2. So, here you have to write minus 2. In the similar way, further if we calculate the values, what will become? Minus 13 minus of minus 9. Minus of minus 9 is nothing but plus 9. So minus 13 plus 9. What is it? Minus 4. Then minus 19 minus of minus 13. Minus of minus 13 becomes plus. So minus 19 plus 13 becomes minus 6. Third order difference values. Minus 4 minus of minus 2. Minus of minus 2 is plus. So minus 4 plus 2. Is it not minus 2? Yes. Minus 6 minus of minus 4. Minus of minus 4 is plus 4. So minus 6 plus 4. Again it is minus 2. Then fourth order difference values. Minus 2 minus of minus 2. Minus of minus 2 in the sense plus 2. So minus 2 plus 2 will become 0. So these are forward difference values whichever we have got. Look at the formula. It is not just delta 1, delta 0, 1. In the sense, in this delta 1 column if we observe, this is delta 0, 1. This is delta 1, 1, delta 2, 1, delta 3, 1. That means this is delta 0, 1. In the similar way, delta 0, 2, delta 0, 3, delta 0, 4. So x, x minus 1, x minus 2, x minus 3, 2 factorial, 3 factorial, 4 factorial, and these delta 0, 1, delta 0, 2, delta 0, 3, delta 0, 4, all those values we have got. And this y naught is nothing but here y naught we have mentioned C, 55. That can be substituted. So now we have got all the values which can be substituted in the formula. Y25 is equal to, why we have written y25? Because yx is the formula. At x value 25, it is asked to calculate y value. That's why yx. In place of x, this x equal to 25 we have written. So y25 is equal to y0. What is y0 value? Here it is there, see. Y0 we had taken 55. So y0 is 55 plus in between, then x into delta 0, 1, x value is 1.5. Delta 0, 1 value is this minus 7. Delta 0, 2 is this minus 2. Delta 0, 3 is minus 2. Delta 0, 4 is this 0. First ever values of all these difference columns will become those respective delta zeros. Delta 0, 1, delta 0, 2, delta 0, 3, delta 0, 4. Now we want to substitute delta 0, 1. So minus 7. Then plus in between, x into x minus 1 divided by 2 factorial. X is 1.5 into x minus 1 is 0.5. X into x minus 1 divided by 2 factorial, that is 2 multiplied by 1, that is 2. Delta 0, 2. Delta 0, 2 value is minus 2. Then plus x into x minus 1 into x minus 2 divided by 3 factorial, that is x value is 1.5 into x minus 1 is 0.5 into x minus 2 is minus 0.5 divided by 3 factorial, that is 3 multiplied by 2 multiplied by 1, that is 6 into delta 0, 3. Delta 0, 3 is minus 2. Then plus in between, x into x minus 1, x minus 2 and x minus 3. X value is 1.5 into x minus 1, that is 0.5, x minus 2 is minus 0.5, x minus 3 is minus 1.5, divided by 4 factorial. 4 into 3 into 2 into 1, that gives you 24, and then multiplied by delta 04. Delta 04 is 0, so multiplied by 0. So next it becomes, that implies 55 as it is, plus into minus, that becomes minus 1.5 into 7, that is 10.5. Then plus into plus, plus into minus, minus. So 1.5, 0.5, this 2 are to be multiplied, and that is to be divided by 2. That becomes 0.75. Then plus into plus, that is plus, plus into minus, that is minus, then minus into this minus, plus. So the sign becomes plus. So 1.5, 0.5, 0.5 and 2. These 4 are to be multiplied, and that is to be divided by 6. What value we are going to get? 0.125. 0.125. And then this entire term, whatever may be the value, it is to be multiplied to this 0, correct? Anything which is multiplied to 0 will become 0. So plus 0. We need not multiply or divide anything here, because it's being multiplied by 0. Anything value we come across here, this as the answer, when it is multiplied by 0, it becomes 0. So that implies 55 minus 10.5 minus 0.75 plus 0.125 has to be performed. That becomes 43.875. Therefore, y25 is equal to 43.875. This is what is to be calculated, it was said. So y values are in terms of crores. It can be written 43.875 crores as the answer. You can have one question now here. Sir, when you are writing this particular formula, yx equal to y naught plus x delta 01, all those, you have written plus so on. Whether should we stop at fourth value or third value? What is the exact value we should stop at? You may ask this question. So we have to observe in that case the given number of observations. Here it is 1, 2, 3, 4, 5 number of observations were given. These 5 observations, look at y values also. Those are 5 in number. When we have taken first order difference, those values became 4. 1, 2, 3, 4. And then further they became 3. 1, 2, 3. And then further they became 2. And then further only 1. Till when one value we get, till there it is to be continued taking these forward differences. Then we will get whether delta 1, delta 2, delta 3 or delta 4 we should stop at. So wherever one value comes, there we have to stop taking the forward differences, because further there is no value here to take difference. Correct. So we have to stop at delta 4 in this given particular value. By chance, the given values are 4 in number. 4 values will become 3, 3 become 2, 2 become 1. Delta 3 only it should stop in that case, and then formula also should stop at delta 3. One such question also we shall solve, which is based on only 4 values given. For the following data, interpolate the value of y when x equal to 35. Once again, here you can observe it has not been given which method to be followed, whether binomial expansion method or Newton's forward difference method. This x equal to 35 we have to observe whether it is among the given x values or not. 10, 20, 30, 40 is given. This 35 is in between these two values. So now Newton's forward difference method has to be calculated. And another thing, how many values are given? 1, 2, 3, 4 values are given. Let's take them down. Y values as y0, y1, y2, y3. Similarly, x values can be written as x0, x1, x2 and x3 values. Then further, we know already forward differences are to be taken. Here 4 values if they are given, first forward difference it will become 3 values, and second forward difference it will become these 3 values, 2 values, and then delta 3 it will become 2 values to 1 value. So delta 3 only it will stop here. Delta 4 need not to be calculated. Here delta 1, that is 30 minus 23, is it not 7? Yes. 34 minus 30, 4, and 37 minus 34, that is 3. Then 4 minus 7, it is minus 3, and then 3 minus 4, it is minus 1. Minus 1 minus of minus 3. Minus of minus 3 is plus 3. So that minus 1 plus 3 will become plus 2. So now Newton's forward difference method formula is yx is equal to y0 plus x delta 0 1 plus x into x minus 1 divided by 2 factorial into delta 0 2 plus x into x minus 1 into x minus 2 divided by 3 factorial into delta 0 3 plus so on. We can stop at delta 0 3 only, because still delta 3 values alone we can calculate, where x equal to x minus x naught divided by h. X value is 35, because x is nothing but the value of x to be interpolated. So that 35 can be substituted minus x naught. X naught value is 10 divided by h. H is the difference between these x values. 10, 20, 30 and 40 it is given. So that 10 is the difference, which is equal to 35 minus 10 divided by 10, which comes as 2.5. Further, we have to calculate x minus 1, x minus 2. That's why x minus 1 is equal to, that is 2.5 minus 1, that is 1.5. Then x minus 2 is also required. So x minus 2 we shall keep it calculated. X is 2.5 minus this 2 equals to 0.5. Now we can go for substitution. Therefore, y 35 equals to, because x equal to 35 it is asked, yx becomes y 35 equals to this y naught value is 23. Then plus in between x into delta 0 1, x value is 2.5 into delta 0 1 is 7. Then plus in between and x into x minus 1 divided by 2 factorial. X is 2.5 into x minus 1 is 1.5 divided by 2 factorial. 2 multiplied by 1 is 2. Then delta 0 2. Delta 0 2 value is minus 3. Then this plus in between x into x minus 1 into x minus 2. X is 2.5 into x minus 1 is 1.5 into x minus 2 is 0.5. divided by 3 factorial. 3 into 2 into 1, that is 6. Then multiplied by delta 0, 3. Delta 0, 3 is this 2. Equals to 23 as it is plus 2.5 multiplied by 7, 17.5. Then now this plus into plus 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 into minus, minus it becomes, so that we have to be extra careful here. Minus this 2.5 into 1.5 into 3 divided by 2 when we perform, we are going to get 5.625. Then further plus into plus 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 into plus again plus plus into plus again plus, all values are plus only, that's why plus it becomes. So 2.5 into 1.5 into 0.5 into 2 and then divided by 6, when you perform you are going to get 0.625. so now all these using calculators plus minus you can do. 23 plus 17.5 minus 5.625 plus 0.625, if you perform in the calculator you are going to get 35.5. so therefore y35 value equals to 35.5. this is the value which was expected to be calculated. This is what the solution for this particular problem. So we have understood now, based on 4 values given as well as based on 5 values given, how to work out Newton's advanced differencing method problems. Now it is the practice time for you. Questions for practice from previous years of board examination question papers are given in the next page. Work them out, get the perfection in working out these examples. Here are few problems based on your previous exam question papers. 1, 2, 3, 4 problems are given. Try to work them out and get the perfection. Thank you. Save the phone number, message in WhatsApp to join WhatsApp broadcast group. Please note, don't call to the given number, only WhatsApp. You can join Telegram group also. Link is given in the description box. If you have liked the video, please press the like button. You can express your views in the comment box. Please share the video to your friends and juniors. And don't forget to subscribe to the channel. Thank you once again. See you in the next video.